Hello student, I am Dr. Ajay Kumar Sinha. Today I am going to discuss nomenclature and isomerism in case of hydrocarbon. In this chapter also nomenclature and isomerism is there. Just it will be focused only in case of hydrocarbon, not in others. Only in case of hydrocarbon, because hydrocarbon chapter is there. Then here also you will revise nomenclature and isomerism. Actually this is very important, and question is asked always. Then now in hydrocarbon I am going to discuss nomenclature and isomerism. Already you know. Now some things examples I will give that will be little different, and again you can revise it with some other example. I will tell some questions also, and some other examples. You have already read about nomenclature of different classes of organic compounds. Last class we have discussed, previous classes I have discussed nomenclature and isomerism in alkane. Only in case of alkane I will discuss only in case of alkanes. Nomenclature and isomerism in alkanes can further be understood with the help of few more examples. Common name I will tell also, and generally it will be written in parenthesis. Okay, parenthesis. First three alkanes like methane, ethane, propane have only one structure. I am telling you only I will tell about alkanes. All examples will be from alkanes, not from others. Actually in every compound, whenever you will study, then for that compound you should know the these things, nomenclature and isomerism for every compound. Just like for alkane, now I am discussing. If you will study alkene, then for that time also nomenclature of that compounds related to alkenes and its isomerism will study. If I will discuss suppose alkynes, then there also you will study nomenclature and isomerism for that particular, you can say, group. If you will study alcohol, ester, carboxylic acid, ketone, whenever you will study carboxyl group, then again there only for that groups nomenclature and isomerism is studied. That is the, you can say, way to study the groups or compounds of that groups. Then like that way here we are briefing nomenclature and isomerism related to alkanes. Then first three alkanes, methane, ethane, propane, have only one structure, but higher alkanes can have more than one structure. Okay, and just I will give example. Suppose a structure for C4H10. C4H10 means butane. How many structures are possible? Okay, let us write structures of C4H10. 4 carbon atoms of C4H10 can be joined either in a continuous chain or with a branch chain. Okay, just I am telling example. You listen carefully, complete today. You have to understand these things. Only molecular formula, one molecular formula is there, C4H10 as for example. Then how many structure is possible, in how many way you will write. Then all the ways in which you are writing C4H10, that is the isomers. Isomerism means same molecular formula. Molecular formula same, structure formula different. Then like that way, if molecular formula is C4H10, then in how many way a structure you can write? How many way? Molecular formula should be there, only a structure should differ. Then here just branched also you have to consider, and a long chain also you can consider. Then here in continuous chain or with a branch chain you can write. Two ways are there. Then first, it is very easy for first chain, long chain, that is the 4 carbons are there, you write 4 carbons. Okay, you can start now from any one side because no other group is attached. Always with a structure, 3 things you have to write. Possibilities are for 3 things. First, a structure, and because your molecular formula is same, then obviously different structure you can write. Then for all these 3 structure, if you have written in 3 ways or 4 ways, then what are their names? Because they will differ in the name of, in the carbon. In the carbon, some branch may be attached, then you have to write that carbon number. Then it will differ in carbon number. Then nomenclature will differ. Same nomenclature will be not there. If 3 structures are there, then 3 nomenclature having same molecular formula. This you have to keep in mind. 3 things. First, different, how many ways you will write. First thing, that number is called, that in that way 3 ways to 4 ways, 2 ways, 5 ways. Then that is all are isomers. Then what are their name? Because the structures are different, the nomenclature will be different. Formula is the same, molecular formula is same. Here we will focus that things. Then now first example, C4H10. How will write? Then butane is there, then at first structure is very easy to write. 4 carbons are there, you write 4 carbons. Single bond you attached. And the rest things, you just hydrogen you fill it. Tetravalency of carbon. Always you count tetravalency of carbon is there. Means each carbon should have 4 bond. Then here a butane case, in case of butane, that a straight chain will be there, 4 carbon, and numbering you can start from any side because no other group is attached. Then one way, normal way you can write butane. Okay, 1, 2, 3, 4 you write 4 carbon, and everywhere 1 hydrogen you write. Then you will find first and last carbon 3 hydrogen will be there, and in between the two carbons are there, both will have 2 hydrogen. 2 hydrogen. If you will count, then you will find that carbon tetravalency is fulfilled everywhere. First and last 3 hydrogen is there. Then 3 valence is over, 4th is attached with other carbon. And that again second carbon is attached to the third is attached to the 4th. That is the last. Then last also 3 hydrogen, and first also 3 hydrogen. And 3 hydrogen first carbon, 3 hydrogen 4th carbon. Hence 3 bonds both sides, 3 valence is over. 4th is used with other carbon. And again second carbon will attach with the third will attach with the 4th. Then now in the middle 2 carbon have only 2 hydrogen. Then now everywhere 4 valency of carbon is satisfying. Always it should satisfy 4 valency. And because it is a normal chain, and it is a 4 carbon means a butane, then it is a normal butane. Its name is only ordinary way, butane you can tell, or it because it is a normal way, a straight way, then normal butane. dash butane. N dash butane, small n. N means normal. N dash, always I told you, just to separate one dash you have to write. Then N dash butane. And it's a boiling point, you should also know, it is 273 K, means 0 degree centigrade. 273 K means what? T is equal to 0 plus T is equal to 0. Then 273 K for normal butane, it will be, its boiling point will be 273 K. Now other structure, how will you write? Molecular, this formula should be same. One, only a structure may be differ. Then second structure you can write that one hydrogen from anywhere you can remove. From anywhere one hydrogen you can remove, and its place one carbon can be attached, means one methyl group can be attached. Okay, one hydrogen if you remove, then there will be, that carbon will have one less hydrogen, and one carbon, generally methyl group, will attach in the form of benzene. Then now second structure you can write in the form of branch. In the form of branch. Suppose now 4 carbon was there, 1 carbon you remove. 1 carbon you remove. Then 3 carbon will be there. Then first and third CH3. Okay. And in the middle, one CH3 what you have removed, that you can attach to the second carbon. Then now we will see molecular formula has not changed. Because in the middle CH2 was there. Then now you have removed, suppose last carbon you have removed. Then CH2 was remaining. Then now from the second carbon you have removed one hydrogen, that will come to the last third. Then there tetravalency is fulfilled. Because one hydrogen is removed and one CH3 is joined. Then that H, where it will go? Then that H will go to the neighboring carbon, it will attach. Then there again, now it became CH3. Then now you can see with central carbon, now left side, right side, down, methyl group is attached. 3 methyl group is attached with that carbon. Left side CH3, first carbon, and last means third carbon CH3, and in the middle, in the center, that is the second, in that CH3 group is attached. Then see 3 CH3 group is attached with the center. Then now you remember what will be the nomenclature. Just to think, 3 CH3 group is attached with the carbon. Then you know this type of, I have told you, tertiary, also you can use the term tertiary, or isobutane. Iso, because 3 CH3 group is attached. If 3 carbons are attached, then you know that is the tertiary. If 1 carbon is attached, only 1 carbon is attached with the carbon, then that is the primary. If 2 carbon is attached with the 1 carbon, then total is becoming 1 extra. With 1 carbon is there 1 carbon is attached, then primary. If 2 carbon is attached, then secondary. If 3 carbon is attached, then tertiary. And total will be 1 more. 3 are there, but 1 they attached to the 1 carbon, and that will be, due to that it become total 4. Then here 4 methyl group is, 3 methyl group is attached with the central carbon. Then it will be isobutane. Isobutane, because including branch, total number of carbon is 4. That's why it is a butane. And it is satisfying tetravalency. In the middle, left side CH3, right side is CH3, down CH3, and what is left out there? Hydrogen is there. Correct? Then its name is isobutane. And other name, what will the other name? Then see, with carbon number 2, that is the center, first, second, third, straight, and one methyl group is attached with the second. Then how will you do nomenclature? You remember. 2 you have to write because with carbon number 2 methyl group is attached. Then you should write carbon number, location you have to write. Okay, that is the at carbon number 2 methyl group is attached. Then 2 methyl with methyl what you are using. Hence 3 only 3 became propane. 3 carbon became propane. Hence 2 methyl propane. You can write 2 methyl because methyl group is attached with 2. Hence 2 methyl propane. And 2 and methyl on dash you have to write. Always just to separate one dash you write. Okay. And you with the same group, with the same carbon atom, if same group is attached with the same carbon, then that time you write 2 2 or 3 3 or 4 4, at which both the same group are attached. 2 2 and same group is attached methyl, then 2 2 dimethyl. If ethyl group is attached at 3, carbon number 3, 2 ethyl group is attached. Then 3 3 3 comma 3 and then diethyl. Like that way you can write. And now here you have written 2 methyl propane, or in bracket you can write isobutane. Okay. This I have told, that is isobutane is common name. Then 2 structure you have written. Now other example you can see. Other example. In how many ways you can join the carbon atoms and 12 hydrogen atoms of C3H12? This is the question. Okay, full now today only examples are there, because you should understand this nomenclature should be easy. Isomers you can write very easily. That is actually purpose. Okay, you have to focus especially on nomenclature and different structures, how many, that is the isomer you can tell, and their name. Then now this C3H12 is there. Next, not C3, C5H12. How many ways you will write? In how many ways you can join the carbon atoms and 12 hydrogen atoms of C5H12. C5 means pentane. Pentane because you are talking about the alkane, hence A and E will be there in the end. You have to not think anything. Then 5 carbon you write, and first you fill it with hydrogen. Carbon should satisfy tetravalency. Then that will be easily you can write 1 will be the 5 carbon you have written, and then first and last they will have 3 bond, means 3H. First carbon 3H, last carbon means carbon number 5th 3H, means 3 bond, 3 hydrogen bond, carbon hydrogen. First carbon will have 3 carbon hydrogen bond, and last 5th will be 3 carbon hydrogen bond. Then in the middle 3 carbons are there. You can start numbering from any side because all are the same. No other group is attached. When other group will be attached, then you have to think from which side you have to give. Okay, that already rule I told you, that where that group should get a list number. And you should attach that carbon should get a list number. Okay, then now here you come to this C5H12. One you have written very easy ways. 5 carbon you have written, and everywhere you filled with the hydrogen. Nothing, very easy. Then it is a pentane, also called, because straight chain is there. Then whenever a straight will be there, use the term normal, a small n, or dash you write, in pentane. And here its boiling point is 309 Kelvin. First two, what I told you, this 2s structure you have written in case of C4H10, then one has 273 Kelvin boiling point, and other structure what you have written in central methyl group you attached, means 2-methyl propane, its boiling point, you think whether it should be more or less. You think in mind that molecular formula is there and 2s structure you have written. Then this both are isomer. Then now boiling point will be for second structure. First structure 273 Kelvin I told you. Second structure, when one methyl group is attached with the middle carbon, then its boiling point will be less or more. Just you think by common sense. It will be actually less always. Branch means branch compound means it will be weak. Always you keep thing in mind. If molecular formula is same, and if it is straight, then they will have more. And if it is arranged, means now just for example I have given you methyl group is attached. Methyl group is attached. Then for this, its boiling point will be less, because molecules will be in tension whenever they will be in the branch. That's why easily it can be broken. Then for this compound, its boiling point is 261 K. 261 K means you can say in boiling point it will be in minus 261. 261 K means what? 273 plus T, that is equal to 261. Then T is equal to 261 minus 273. It will come in minus, means 12, minus 12. Okay. Now here you can see other example, pentane I was discussing. In that one structure you have written in a very easily pentane, direct way, straight line, and its boiling point is 309. 309. Now same other ways, how will you write? C5H12, how will you write? Then how again? Numbering you can write. 5 is there, then 1, 2, 3, 4 you can write. And now like what I told in the first case, here also one CH3 attached. You can attach anywhere, because out of 5, fifth one you have removed CH3, then 4 is remaining now. First and last, 1, 2, 3, 4. 4 is the last. Then in the middle 2 carbon is there. 2 carbon is there. Then 2 option is there. That methyl group can attach with carbon number 2 also and carbon number 3 also. Both options are there. Any one it can attach. Then already carbon number you have start given 1, 2, 3, 4. First and fourth they have can say tetra valency is completed, and there it will not attach. Only possible is for second and third, because they have CH2. In the middle always CH2 will be there, and in the end always will be CH3 if other group is not attached. Then this 2 and 3 anywhere methyl group can be attached. Suppose now you have attached with second, then what will be the nomenclature? Very easy. Now it is a butane. because total 5 are there, but 4 is a state. Fifth one you have joined with 2. Then 2-methyl butane. It became 2-methyl because carbon number 2 methyl group you have attached. Then now it became 2-methyl butane because carbon number 2 methyl group is attached. But what is the common name? Then common name will be now isopentane. Common name will be isopentane because 4 is a state and 1 methyl group is attached. Then including this methyl group, total carbon is 5 and it is a branch. It became the branch. That iso term is used for branch. Iso term is used for branch. Whenever branch will be there, you can use the iso. Iso term you have used, and it is a total became 5 carbons, then pentane. Now here again I am asking question that now in this two, first one has 309 Kelvin boiling point. Then second will be what? Less or more. Then this will be again less. But difference will be not too much. Little difference will be there of temperature. Then here its boiling point is 301 Kelvin. 301 Kelvin because branch is there. One branch is there. Now third way also you can write. Already you are knowing. I told you that 2 option is there. Then now what you can do that with these things 5 are there. Na? Then now this 3 you write straight away 1, 2, 3 and 2 methyl group you have removed. 2 methyl group you have removed. Okay, means CH3, 2 CH3 you are using. Then obviously 2 hydrogen from the carbon, 2 hydrogen will go. It is obvious because 2 methyl group will attach. Then that carbon, from that carbon 2 hydrogen it will go. Then that 2 hydrogen where it will go? You will remove. But where it will go, that 2 hydrogen? Then see, in the middle CH2 was there. Because 2 carbon you have removed. Suppose you have removed first and last. Then only first and last, only 3 are remaining. Then where hydrogen is lacking, then where is a less, there that hydrogen it will go. From that carbon it will go where they are lacking or lagging hydrogen. There it will go. Then now where CH2 was there, that will become CH3. Simple way, tetravalency you have to maintain. Then you have maintained this CH3, the number of hydrogen is same, number of carbon is also same, only that you have arranged. Then now suppose carbon number 2, both, obviously only carbon number 2 will remain. 3 state, then 2. Then first and last CH3 is there. Then they are maintaining tetravalencies. Hence there is no question of attaching there first and third. Because fourth one is attached with the carbon. First carbon and third carbon, their fourth valency, what is remaining, that is attached with the middle carbon. Hence there is no question. Only that option is there, central. Then both methyl group will attach with the second. Then now what all things are, hydrogen is also 12, carbon is also 5. Then what will be the name? Now we can see. Already I have just revised you that in the same group, in the same carbon 2 group is attached, methyl. Carbon number 2 methyl group is attached. Then what will be the nomenclature? Carbon number 2 comma, again 2, 2, 2, because 2 times methyl group is attached with carbon number 2. Hence 2, 2. After that, dash you can give dimethyl, because same group is attached. Same group is attached on that second carbon. Then 2, 2 dash dimethyl, then propane. Dimethyl propane. Correct? Because finally it is a propane. Dimethyl already what you are using. Hence 5 you can't write. You write in the form of propane. When you are counting already methyl, dimethyl, then now you have to not write pentane. You have to write now long chain. What is that? That is the propane. And so 2, 2 dash dimethyl propane. And what will be its these things common name? Then now see the structure. Central carbon is attached everywhere with methyl group. Left right methyl group. And now in the center 2 methyl group attached, then one up, one down. Means everywhere methyl group is attached with the central carbon. Then total became 4 methyl group is attached. 4 methyl group is attached with the central carbon. Then its special name is there. What is a special name? Iso will be there. Not iso, neo. Because everywhere all 4 valence is attached with methyl group. CH3, 4. Then that is called neopentane. You are not using any methyl and this that. Total 5 is there, total 5 carbon. Then when 4 methyl group is attached with the carbon, then term neo is used. Neo and total number of carbon. The neopentane, because it is alkane. Neopentane. Now you think 3s out of this 3s structure, who will be having a lowest boiling point? Second was 301. First one was 309. A straight chain. And one branch was there. Then 301. Now 2 branches there, up and down. Then now what will be its boiling point? More branches there. Then now its boiling point will be further less. 282.5 Kelvin. Less than second one. 301 less than, now it is 282.5 Kelvin. Then why it happened like this? Because 2 branches are there. As the branches will increase, boiling point will decrease. And why it will decrease? Then when molecules will be in the branch, then they will be in more tension. That's why it's tension means it can break easily. Bond can break easily. That's why its boiling point will be less. Then in isomer, now here 3 isomer you have written. In second case, C5H12, 3 structure you have written. 3 structure, 3 isomer. In first one, C4H10, 2 structure you have written. Correct? 2 isomer. Then now you have seen this in C4H10. In case of butane, structure 1 and structure 2 possesses same molecular formula but differ in their boiling points. Boiling point difference is not too much. Always you keep in mind 10 degree, 15 degree, 6 degree, 7 degree, like that way. Then the structure 1 and second possesses same molecular formula but differ in their boiling points. Actually you can separate it. Fractionating column will be there. Then all 2 compound in case of C4H10 you can separate it. because boiling point is different. Whatever will coming in that boiling point, all liquid whatever will come, that will be the same compound. After that, what is second compound boiling point? Whatever liquid will boil at that temperature, that will be second compound. Like that way, this three isomer, what I told you, you can separate it according to the different boiling point. First, low boiling point, whose boiling point is low, just they will boil first, then that you can separate it. After the second boiling point, what is the temperature? If it will come, it means now that liquid only it will separate, not the third. Then you can separate it. Until you will separate, completely it will separated, their boiling point will not change. This you should always remember. Until last drop, all will be distilled, boiling point will, or even for melting point also, will not change. Until the last point is distilled, finished. Only then second compound will boil. Okay. And like that way 3, 4 if are there, all 4 can be separated according to the boiling point. Here again I am telling you that whatever be isomers, boiling points will be different, and one compound will have only one boiling point, no other compound. If any compound has the same boiling point, it means both are same. Every compound has their own boiling point or own melting point. Always remember. Now come to the other compound 3 structure. Then third, fourth, fifth other compound C5H12 I am talking about. Third, fourth and fifth, these 3 compound possesses the same molecular formula but have different properties. All 3 have different properties. First 2 also was having different properties. That is the characteristics of isomers. Okay. Then these 3 have different properties. Same molecular formula but have different properties. Structure first and second are isomers of butane. Already told you. Now, whereas structure third, fourth and fifth are isomers of pentane. Now I think it is clear by these 2 examples. Okay. Since difference in properties is due to difference in their structures, they are known as structural isomer, because they are differing in a structure only. Hence, they are also called structural isomers. It is also clear that structure 1 and structure 3 have a continuous chain of carbon atoms. Here, structure 1 and structure 3 have continuous chain of carbon atoms, but this first and third, yes, structure 1 and structure 3 have continuous chain of carbon atoms, but structure 2nd, 4th and 5th have a branched chain. Such structural isomers which differ in chain or chain of carbon atoms are known as chain isomers. Where all things are same, molecular mass is same, molecular formula is same, but now that if you can say they will differ in branch, then why here that in case of second you can see this structure 2nd, I am talking about C4H10, both side CH3 was there, correct, and middle branch was there. Then this is called a chain isomer. chain isomer. Okay, because they are differing in chain. This I told you that a structure first and a structure third. Here you can see you mix both C4H10, C4H10. Then first structure was branch, not branch. This it was a straight. First structure is a straight C4H10, and C5H12 first structure was also a straight. Both were normal. Both were normal. Means continuous chain, continuous branch chain. Then that is a one type of chain isomer. Okay, and that second, fourth, and fifth, they have a branch. All second structure of C4H10 branch, and here also in C5H10 last two structure have a branch. Then these are the example of chain isomer. Because one by one you can understand that in the second example C5H12 two structures have same molecular formula. Okay, but they are differing in their chain. One was a straight chain. First case structure was a straight chain, and second they are differing. A straight chain was there. Now second and third is the branch. Molecular formula is same. Then it is called. These are the example. These three example are you can say chain isomer. Okay. Then this is the structural formula. All are the structural isomer. In a structure also it is called because they are in the different chain. Then this first structure of C4H10 and first structure of C5H12 both are similar. That is the only in the form of a straight line. Hence both are same type of structure, but second structure of butane, and after that fifth and sixth structure, last two structure of pentane. What we are saying, all are in a branch. Then branch means that will be called chain isomers. They are differing in chain. Then this I have told about the you can say chain isomers. Thus you have seen the C4H10 and C5H12 have 2 and 3 chain isomers respectively. Okay, C4H10 and C6H12 have 2 and 3 chain isomers. Okay, have 2 and 3 chain isomers. One is a form of two structure straight way, and 3 are in a branched way. Correct? Then 2 and 3 chain isomers respectively. Okay. Now some question is there. I am again discussing. Now I want to clear your concept. That's why more example I am telling you. Based upon the number of carbon atoms attached to a carbon atom. Based upon the number of carbon atoms attached to a carbon atom, the carbon atom is termed as primary. Already I told you, termed as primary, 1 degree. What we are telling, 1 degree. Primary. Secondary means 2 degree. Tertiary means 3 degree. Quaternary 4 degree. Carbon and carbon atom attached to no other carbon atom as in a methane. In carbon, no other carbon is attached. In methane, that carbon has not attachment with any. That is called no other carbon atom as in methane, or to only one carbon atom as in ethane. In ethane, two carbon only will be there. One is attached to the each other also equal to. Then if no other carbon atom is attached, or if only you can say like ethane, only they are attaching one is to each other, ethane, then that is called primary carbon atom. If no other carbon is attached, okay, carbon atom attached to no other carbon atom as in methane, or to only one carbon atom as in ethane is called primary carbon atom. Primary carbon, methane is also primary, and ethane only one carbon is attached with other carbon, then that is called primary. And if two carbon is attached, then secondary. If three carbon is attached, then tertiary. Primary when one carbon is attached to one carbon. Secondary when two carbons are attached with one carbon. Three carbon is attached to that is tertiary. If four carbons are attached, four carbons are attached to a one carbon, means total five. That will be the middle, and that is called quaternary. Okay, this I have told you. Then now question I am telling you, you can solve it. Write structures of different chain isomers. Chain isomers you have to write. Write structures of different chain isomers of alkanes corresponding to molecular formula. Now C6H14. If C6 is there, then what will be the compound? Easily you can find out. If C6 is there, then how many hydrogen will be there? Double plus 2. Double plus 2 because it is alkane. Means 14. C6H14. When carbon number you are knowing, then hydrogen automatically you can know because you are knowing the formula. Double plus 2 in case of alkane. Then C6H14. Also write their IUPAC name. Okay, first structure you write and then IUPAC name. For C6H14 means how many isomers are there, chain isomers. You have to write chain isomers. Then simply first write the isomer. You have to come to the branch. Then first structure will be easy because 6 carbons are there. Then hexane you can write, normal hexane. Easily you can write a small n dash and hexane, H capital HEXANE. That easily you can write first structure. 6 carbon, total 6 carbon you have to write, and everywhere you fill it by hydrogen. First and last should be H3S3. First carbon should have 3 hydrogen, last should be 3 hydrogen. And after that first structure you will write very easily. Second structure you are writing actually isomer branch. Obviously one carbon you can remove as a methyl group and you attach wherever you want in the middle. Only in the middle carbon you can attach anywhere. Any carbon you can attach. It will be branched. That will be isomer only. And so now suppose second structure you have, second structure you will write. That time it will be 5 carbon because one carbon you have removed, CH3, and then obviously suppose in any other carbon it is going to attach. Then from there one hydrogen will go, and that hydrogen where will it go? Then it will go to that carbon from where that carbon has come, because that will lacking behind by one hydrogen. Hence it will go to satisfy the tetravalency. Or you can understand, always hydrogen replaced. Hydrogen will be replaced to that carbon where hydrogen is less. Very simple way. Then now suppose it has attached to the second carbon. Methyl group is now attaching to the second carbon. Then this is the second isomer. Then first name you have given normal hexane. Then now for this second structure you have written, what will be the name? Then now it is carbon number 2. You start with any side, you can write 1 1. You can start 1 from any side, 1 2 3 4, because same all are same. Then now carbon number 2 methyl group is attached. Then what will be the name? 2-methyl pentane, because 6th one you have carbon removed and it attached as a branch. Then all molecular formula will be the same, only the structure is differing. That's why it is isomer. Then this is the second one. Third one now many options are there. Then third one, now it will attach to the third carbon. Then now again it will be pentane, but now it will be 3-methyl pentane. 3-methyl pentane, because now that methyl group which was attached with the second carbon, now you have attached with the third carbon. That's why the methyl pentane, both are pentane. Now next you can say this structure. Next structure, the next structure will be, now suppose now one more carbon you have removed. Then now 2 carbon you removed means as a methyl group. Then now this will go to the only in the middle 2 carbon. What is remaining? Now it is a total 4, because 2 have removed. Then 4 carbon is remaining. Then first and third will be CH3, and in the middle 2 carbon was there, CH2. Then 11H will replaced, and in that place CH3 will come. Then these 2 hydrogen will again it will go to the needy carbon where they require hydrogen. Then first and last will be the CH3, and in the middle 2 carbon was there. Then 1 hydrogen gone, in its place 1 methyl group attached. Then now it will state chain is became a butane, and 2 methyl group is attached with carbon number 2 and with carbon number 3. Then you can write 2,3 dash dimethyl pentane. And one more possibility is there, one more carbon you remove, or even you are in the term of you can say butane. Suppose you want to write again in the term of butane, then what is the possibility? That both methyl group can attach to the same carbon atom also. Both methyl group can attach to the same carbon. Suppose carbon number 2. Then now 2 from that carbon, both hydrogen gone, and it went to the needy carbon to maintain the tetravalency of carbon. Then now carbon number 2 methyl group is attached. Then what will be the name? Already you know, 2 dash dimethyl, what long chain is butane. Then 2 dash dimethyl butane. Okay. Then these all these structures are called are the example of chain isomer. Okay, chain isomer. This total 5 you have written. Then all are here chain isomer. Okay, I think you have understood what is the chain isomers. All 5 structures are chain isomers. Now I have told you one more thing, sir. Terminal carbon atoms are always primary, because no other things are there, only one carbon is there, and the end, with the end only one carbon will be attached. Hence, always terminal carbon atoms are always primary. Carbon atoms attached to two carbon atoms. Any carbon atom, not atoms, carbon atom attached to two carbon atoms is known as secondary. Correct? I already told you, again I am telling you. And tertiary carbon means what? Tertiary carbon is attached to three carbon. And like that way, neo already you know. Neo or quaternary. Either you tell quaternary or neo carbon. Okay, is attached to four carbon atoms. One carbon is attached with four carbon atoms. That is called quaternary or neo. And it is also represented as, for the primary 1 degree, for the secondary 2 degree, and for the tertiary 3 degree, and for the quaternary 4th degree. Okay. Then this I have told you. And like that way you can go for now up to 5 I told you, C5, C6, then what will be the H14, C6, H14, C7, then 7 into 2 plus 2. This C6, 6 already told you, 6 into 2, 12 plus 2, 14. If 7 is there, then hydrogen will be 7 into 2, 14 plus 2, 16. Okay. And if 8 is there, then 8 into 2, 16 plus 2, 18. Then for all this compound, you can write the, easily you can write the isomers, a different type of isomers. But here, one to common I am telling you that C6H14 has got 5 isomers. I have told you. C6H14. No, I had told about the given example for C5H12 and C6H, I have given example C6H14. C6H14 I have given example, question was there, that was for C6H14 only. Now if 7 is there, then here you have seen C6H14 has got 5 isomers, you have seen. Just now I have, in the question it was given, 5 isomers. Like that way, C7H10, C7H16 has 9 isomers. Question is asked. Question they will ask only, they will tell C7H16 is there. How many isomers will be there? Then you remember 9. And this if C10 and H20 is there, then C10 H22, 10 is the 10 into 2 plus 2, 22. C10 H22 have 75 isomers. Then they will not ask so big, but now this you can keep in mind that C10, as the number of carbon will increase, isomers will be more and more. Reasoning you are knowing, because possibilities will increase. 75 isomers for C10H22. Okay. And the but common they will ask, that also you can write and find out. Then C7H29. Other already you have seen. C6, C7 already told you. 8 onward it will be long. Okay. And all structure will differ by CH2. Okay, already told you. Methyl group is attaching, but in homologous series they will differ by CH2. And in all isomers they are differing. You have seen in a structure second, fourth, fifth, in C5H12. you have observed that CH3 group is attached to carbon atom, number as 2. Okay, like that way we have seen this other examples also. Anywhere they can attach where it is a possibilities. Then many other examples are there. Next class I will tell. Okay, here more you require more practice. Then now some more examples are there. And in that some is asked in examination also. I will tell in the next class. Thank you.